Hey, everybody. So we are looking at the 15.4 worksheet today, dealing with our three new equations, the chord product theorem, secant, and tangent secant. I'll be basically doing one of each. So just stick with me, and then you can try these on your own. All right, so taking a look at the very first problem, we can see that we have two chords crossing one another here. So, this is using our chord product theorem. This is the most straightforward, of the three. Basically, we're just multiplying the two parts of one chord, and we're setting that equal to multiplying the two parts of the other chord. Okay, so let's try that out with number one. All right, I like to start with my chord that has my variable. So I'm going to start with a 5 times x. Okay. And then set that equal to multiplying the two parts of the other chord, a 4 times 10 or a 10 times 4. It doesn't matter what order you multiply them. All right, and yeah, that's setting it up pretty straightforward. From here, we have a 5 times x, which is a 5x, and a 4 times 10, which is a 40. And then dividing by that 5, it looks like x equals 8. All right, if you'd like to pause the video and try out number two, you can, and then we can move on. All right, so looking past this, I'm not going to do 3 and 4, but this is the same type of problem, just with more complex values. When you write this out, for example, you'll have an 8 times a 7x plus 1. Put that 7x plus 1 in parentheses because you'll have to distribute. Okay, but I'm going to do another problem in a bit that it looks a bit like this. All right, so jumping down from here, we get into looking at two secant lines crossing. This is our secant product theorem. The big thing about this is when we go to multiply the two parts, what we're doing is we're multiplying the outer segment times the entire secant line. Okay, be really careful. It'd be tempting to do, just this part times this part. It's not, doesn't work that way with the secant product theorem. All right, so let's try. All right, taking a look at number 7. All right, I'm gonna, both of these have variables, and it doesn't matter which one you start with. Let's just start with this one here. All right, so when we go to do this, always start with that outer segment. So I'm gonna start with the 5, and then I'm gonna multiply it times the entire segment, which is not just the x, it's the x plus the 5, the whole thing. Right? And then setting that equal to doing the same thing on the other side, taking the outer segment, 6, and multiplying it times the entire thing. Be really careful. It would be tempting just to put an x minus 3 in here. Okay, but that is not the entire line. The entire line is an x minus 3 plus a 6. Okay, once you get this set up, you can kind of go from here. Let's see. I guess the first thing I'm looking at, there's nothing to do inside the parentheses here, but we do have this that we can combine. So I think I'm going to make that just my next step. I'm going to bring everything else down for now. Okay, so inside here, -3 plus 6, be careful with that. That gives us a positive 3. Okay, so from here, now we can distribute the 5. We'll also distribute the 6. So we got 5 times x, 5x, 5 times 5, 25. On the right, 6 times x, 6x, 6 times 3, 18. Okay, next thing I notice is we have variables on both sides. We need to get them to the same side. Just remember, we can move either one of these, the 5x or the 6x. We get the same answer. Okay, I'm going to move the 5x. Okay, so they're gone over here. I have a 25 on the left. On the right, 6x minus 5x. I got a 1x, or just x, plus 18. Okay, and then, yeah, we can get rid of the 18 by subtracting. And 25 minus 18 gives me 7. I'm going to flip it around. X equals 7. Okay, I'm just, checking the directions. All of these just want you to find x. So when you do that, you're done. Okay, so I think this would be a good one to pause the video, try out number 8, and then we can move on. All right, so moving on from here, we get into a tangent and secant line. This is using the tangent secant product theorem. Okay, this is basically the same formula as the secant secant product theorem. The only difference is that our tangent line, we are squaring it, basically doing the outer segment times the entire thing. We're multiplying it times itself. Okay, so it is technically the same formula, but just think, if you see a tangent line, you square it. All right. And then the secant line follows the same rule, the outer segment times the entire line. Okay, so let's try it out. Okay, taking a look at number 11. Okay, so when you guys go to start with these, start with the tangent line, okay, squaring that. Okay, so that's where my variable is falling. I got an x squared. Okay, and then the secant line, we're taking the outer segment 4 and multiplying it times the entire line, which is a 4 plus 5. Okay, if you wanted to just put a 9 in there, that's fine. If you do that addition in your head or your calculator, I'm going to write it out. All right, cool. So on the left, the x squared comes down. On the right, we can, combine those to get a 9. And then 9 times a 4 gives us 36. All right, and then undoing the squaring by square rooting. Looks like we're getting x equals the square root of 36 if you need to type it in, but it is a perfect square. We get plus or minus 6. All right, but I just want to point out the minus 6 we ignore. It doesn't make any sense for this to be a negative 6 length segment. Okay, there it is. Okay, I'm going to do one more of these, and then I'll leave the rest to you. All right, jump down to number 13. All right, weirder values. These are going to complicate these problems a little bit. So let's just see where it goes. So first thing, let's go ahead and square our tangent line. So x plus 5, that whole x plus 5 is going to be squared. Okay, and then we'll do our secant rule, outer segments, which is x plus 1 times the entire segment, which is adding together the two parts, and x plus 1 plus 10. Okay, just be really careful. Take your time when you set these up. Okay, so on the right, let's see. I'm going to do a couple things in this step. The first thing, I'm going to write this x plus 5 squared as an x plus 5 times an x plus 5. Okay, over on the right, I'm going to combine the 1 and the 10 as well. So I'm going to bring down this x plus 1. Okay, and then inside of here, I have an x, and that's going to give me an 11. Okay, just to make this look nice, I'm going to put parentheses around the x plus 1 just to kind of show that, all right, we got two binomials over here, two binomials over here. Like we're going to be doing the same type of distribution on both sides. Okay, and yeah, that is the next step. We have a bunch of distribution. So I'm going to distribute the x, and then I'm going to distribute the 5, and then we'll do the same thing on the other side. Okay, so let's start with the x. X times x is x squared. X times 5 is a positive 5x. Okay, 5 times x gives us another 5x. 5 times 5, 25. Okay, over on the right, same idea. We're going to distribute the x, and then we'll also distribute the 1. Okay, x times x is x squared. X times 11, positive 11x. Okay, distribute the 1. 1 times x is a 1x. You can write it as 1x or just x, however you want to do that. And then 1 times 11 is 11. Okay, so a couple things I'm going to do on the next step. First thing, I have these x squareds on both sides. We saw this, I think, recently. When we go to take them to the same side, subtracting the x squared. Okay, the nice thing about that is we are eliminating the quadratic on these. So we don't have to deal with that. That's good news. Okay, we can also combine our x's on both sides. So a 5x and a 5x is a 10x. Bring down the 25. Over on the right, 11x and a 1x is a 12x. Bring down the 11. All right, we're getting close. Next thing, we have our variables on both sides. Let's get them to the same side. I'm going to choose to move the 10. Okay, and I just want to remind you, the reason why I'm moving the 10 is I look ahead and I know that I'm going to get a positive number from here. I always suggest dealing with positives if you ever can. Okay, so 25 on the left, on the right, we've got a 2x plus 11. Okay, and then from here, we just have a little two-step equation. Okay, I'm starting to just do this stuff in my calculator. I know I'm going to subtract the 11, divide by the 2. So 25 minus 11, we got a 14 equals 2x. Divide by 2. I'm going to flip it around. X equals 7. Alrighty, so yeah, that right there, that's some good old fashioned algebra. I do maybe recommend check out the next problem. I think it's number 14, right? Okay, that is a lot like this problem. Go ahead and give that a try. If you have a question on that, definitely call me over and we'll talk. All right, see you guys.